A quadratic is a second degree equation. It is a polynomial having highest degree as 2. A quadratic equation is given by ax squared plus bx plus c equals to 0, where a is the coefficient of x squared, b is the coefficient of x, and c is a constant that has no variable attached to it. So the quadratic equation is arranged in the decreasing order of the degree, where the highest power is written first, the first is written later, and the constant is written at the last. Alpha and beta are the solutions or roots of the quadratic equation. They are also called as the zeros of the polynomial or zeros of the quadratic. The sum of these roots of quadratic are given by negative b over a, where negative b is the coefficient of x and a is the coefficient of x squared. This is also termed as s, where s is the sum of roots or sum of the zeros of the polynomial or the quadratic. Alpha into beta is the product of the roots or product of zeros of the quadratic, that is given by whose magnitude is given by c over a, and it is written or it is expressed as p, that identifies or signifies the product of the roots. A quadratic is given in terms of s and p. The quadratic is given as ax squared minus sum into x plus the product equals to 0. Note the change in sign. If we are expressing it as ax squared plus bx plus c equals to 0, in terms of sum and product, we express it as x squared minus sx plus p equals to 0. The roots of the quadratic can be calculated or can be found using different methods or different ways to find the zeros of or roots of the quadratic. This method to find the roots of the quadratic is the method that is using quadratic formula. In this formula, we use x equals to negative b plus or minus root over b squared minus 4ac divided by 2a. Now this plus or minus sign identified that the square root of any positive integer is positive or negative, and therefore we write plus or minus if this term b squared minus 4ac is known as the discriminant of the quadratic. This discriminant is used to find the nature of the roots of the quadratic equation. Since it is a second degree equation having highest degree as 2, the quadratic will always have these two roots can be different roots. These two can be identical, or if the quadratic can have imaginary roots. Now, how do we find the roots of the quadratic? When we plug these values, b identifies the coefficient of x, a identifies the coefficient of x squared, and c is the constant. If b squared minus 4ac, the magnitude of b squared minus 4ac is known as the discriminant, which is denoted by a delta or a capital D. If d is greater than 0, then the roots of quadratic are real and different roots. If the value of d is equal to 0, then the quadratic has identical roots. And if d is less than 0, that is if the discriminant is a negative value, then the quadratic will have imaginary roots. These imaginary roots have root over a negative number. Any negative number under the root. Let us say, for example, let us say root over negative 16. So this negative is the imaginary part of the imaginary root. A quadratic can be factorized by completing the square method. While using this method, we can use the identity a plus b whole squared equals to a squared plus 2ab plus b squared identity, or we can use a minus b whole squared equals to a squared minus 2ab plus b squared identity. Occasionally, we use a plus b into a minus b equals to a squared minus b squared identities. Understanding, learning, and by hearting these identities is very much necessary so that it can be applied in factorizing the quadratic by completing the square method. If we don't know these identities, then Factorizing by completing the square method cannot be achieved. Okay, now let's consider the example p squared plus 14p minus 38 equals to 0. Here the middle term is positive, right? So we will try to put it in the identity of a squared plus 2ab plus b squared. Okay, let's go ahead. So we have p squared plus 2 into 7 into p minus 38 equals to 0. Okay, now if we see, we have p squared. Okay, then we have plus 2 into 7 into p. Okay, and I'll write this negative 38 a little far away so that I can introduce certain term without changing the meaning of the given quadratic. Okay, if we see here, we have a squared plus 2ab plus b squared. So here we have p squared plus 2 into 7 into p, and now the p squared is present, 2 is present. We need the square of 7, so we add 49 and we subtract 49. Okay, so adding and subtracting the same term doesn't change the meaning of the given quadratic. Okay, so here let's expand it. So we have p squared plus 2 into 7 into p plus 49 minus 49 minus 38 equals to 0. Okay, now this is same as identity p plus 7 whole squared minus, we add these two. When we have two negatives in addition operation, we do the simple addition with negative sign. So 7 carry 1 and then we have 8 equals to 0. Okay, now this can be written as, let us try to put it in this identity, which is a plus b into a minus b. Okay, why is it can be placed in this identity? See here, p plus 7 whole squared minus root over 87 whole squared equals to 0. So this is a squared minus b squared identity, right? This can be expressed, or this can be rewritten as p plus 7 plus root 87 into p plus 7 minus root 87 equals to 0, remains as it is, because all along we have the LHS and RHS. So equals to 0 will appear at every step. So finally we can say that p squared plus 14p minus 38 equals to 0 can be factorized as p plus 7 plus root 87 into p plus 7 minus root 87. To factorize the quadratic using midterm splitting method, we must multiply the a, the coefficient of a squared, x squared, and the c, that is the constant. So we get the product of the terms as here in this example. We find the product of a and c as 6 into negative 6. The product is negative 36. Okay, now we will factorize negative 36 in such a way that the sum of the product, the sum of the factors is positive 5. Let's go ahead factorizing negative 36. So here I'll first write the product, which is p, and sum of the factors as s. Okay, let's go ahead. So we have negative 36 and the sum is positive 5. Okay, let's go ahead writing the factors now. The negative 36 can be factorized as 1 into 36. I'll not write the product sign here. 1 into 36 into 18 into 12 into 9, and 9 into 4, 5, 6 into 6, and 7, 8 and 9. Again, now from here the factors will repeat. Okay, now since product is negative, if we go to these integer rules, okay, if we see the product is negative, the only case, the case where product is negative is here. So when either of the factors is negative, then the product is negative. Now, if we jump to the sign of some of the factors, we see that some of the factors is positive. So here, normal subtraction will be performed and the sign of greater number will be assigned. That means here our greater factor is positive and smaller factor is negative. Okay, let's assign signs now and here. And here it's the greater one is positive. Okay, this step is very important. It is necessary we write the integer operation rules and we make this table. It's absolutely necessary so that we can take the factors as required. Okay, let's go ahead. So here some of the factors, positive 36 minus 1 gives us positive 35. 18 minus 2 gives us 16. 12 minus 3 gives us 9. 9 minus 4 gives us 5. So this is a required pair. So the middle term 5 can be split into minus 4 plus 9. If we see minus 4 plus 9 gives us negative 36 and minus 4 plus 9 their sum gives us positive 5. Now, coming back to the given quadratic, we can say 6x squared plus 5x minus 6 can be rewritten as 6x squared minus 4x plus 9x minus 6. Okay, now further we group them into two. Let's take the highest common factor. In this, it is 2x is the highest common factor. So highest common factor, I'll write it in the other font. Okay, the other color we have, I'll take 2x common, it 3x minus 2, and I'll take 3 minus 3 common. I'll take plus 3 common. So this gives us 3x minus 2. Now these two, 3x minus 2 are common terms. So I'll take them as 1 and 2x plus 3. So our given quadratic 6x squared plus 5x minus 6 can be factorized using middle term splitting as 3x minus 2 into 2x plus 3. Let's verify the product here. The product can be verified. Let's go ahead. So we have 3x minus 2 multiplies, okay. So here 2x multiplies this, 2x multiplies 3x minus 2 and plus 3 multiplies the distributive property I am using here. So we have 6x squared minus 4x plus 9x minus 6. Now 6x squared is as it is, minus 4x plus 9x gives us plus 5x and minus 6 as it is. It matches the given quadratic. The midterm splitting method to solve quadratic, first of all we have to write integer rules on the same page. Secondly, we have to make this table so that factorizing the given product and finding its sum, assigning the signs to the larger and the smaller factors becomes easier. It becomes very easy to pick up the factor that matches the given condition. Second degree equation, that is the quadratic equation, can be factorized using the quadratic formula. The quadratic formula is x equals to minus b plus or minus root over the discriminant, which is b squared minus 4ac divided by 2a. Let us try factorizing this quadratic equation. 2x squared plus 9x plus 10 equals to 0. The coefficient of x squared is a, which is 2. The coefficient of x is b, which is 9. And the constant is 10. Let's plug these values in this quadratic equation. We get in the quadratic formula, we get x equals to negative 9 plus or minus root over 9 squared minus 4 into 2 into 10 divided by 2 into 2. Let's calculate. So negative 9 plus or minus root over 81 minus 80 divided by 4. 4 2s are 8, 8 10s are 80. Now we can say x equals to negative 9 plus or minus root over 1 upon 4. If we simplify it, the square root of 1 is plus or minus 1. So we have minus 9 plus or minus 1 divided by 4. So once we calculate x using x equals to 1, using plus 1, we get x equals to minus 9 plus 1 is minus 8 over 4 is minus 2, and x equals to minus 9 minus 1 is minus 10 divided by 4 is minus 5 over 2. So the zeros of the quadratic 2x squared plus 9x minus plus 10 are x equals to minus 2 and x equals to minus 5 over 2.